Correlation. Correlation analysis is a statistical technique used to measure and analyze the strength and direction of a relationship between two or more variables. It provides insight into whether and how variables are related without establishing causation, widely used in research across disciplines like social science, business, and healthcare. Correlation analysis helps researchers identify patterns and relationships in data. Importance of correlation analysis: identify relationship, helps uncover pattern between variables, determine whether and how two variables move together. Predictive insight provides the basis for predicting one variable based on another. When two variables are strongly correlated, knowing the value of one can help predict the other. Support decision making. Assist in formulating hypotheses and guiding strategic decision. Understanding correlation helps in formulating strategies and making informed decisions. Foundation for further analysis. Serve as precursor to more complex statistical technique like regression analysis. Correlation analysis is often a starting point for more complex analysis like regression. It helps decide which variable to include models that explore cause and effect relationship.
Types of correlation. Number 1. Positive correlation. Definition: both variables increase or decrease together. This means that as one variable goes up, the other one tends to go up too. Or if the one goes down, the other goes down as well. Example: higher education levels are often associated with higher income. This suggests that as education level increases, income tends to increase too. Number 2. Negative correlation. Definition: one variable increases while the other decreases. In other words, as one goes up, the other goes down. Example: increased exercise is associated with lower body weight. This means that more someone exercises, the lower their body weight tends to be. Number 3. Zero no correlation. Definition: no relationship exists between the variables. Change in one variable do not predict change in the other. Example: shoe size and intelligence show no correlation. A person's shoe size doesn't affect or indicate how intelligent they are. Understanding correlation is useful in research, business, healthcare, education, and many other fields. It helps in identifying patterns, making predictions, and guiding decisions. However, it's important to remember that correlation does not imply causation. Just because two variables are related doesn't mean one causes the other. This image shows positive correlation, no correlation, and negative. Number 1. Positive correlation. R equal 0.4. The dots in the scatter plot generally move upward to the right, meaning as one variable increases, the other also tends to increase. Line direction, upward slope. R equal 0.4. This indicates a moderate positive correlation. Not perfect, but there's a clear trend of both variables increasing together. Number 2. No correlation. R equal 0. The dots are scattered randomly with no visible trend. This means there is no relationship between the two variables. Line direction, flat horizontal, showing no upward or downward trend. R equals 0. This value tells us there is zero correlation. Number 3. Negative correlation. R equal negative 0.4. The dots generally move downward to the right, meaning as one variable increases, the other tends to decrease. Line direction downward slope. R equals negative 0.4. This indicates a moderate negative correlation, not strong, but there is noticeable trend.
The next topic is all about methods of correlation analysis. The first methods of correlation analysis is the scatter diagram. This is graphical methods of studying the correlation between two variables. Each pair of value is plotted on the graph paper as the number of points. If these points show any trends, the two variables are not correlated. Correlated can be measured through three different methods: scatter diagram, correlation graph, and coefficients of correlation. So, scatter diagram is a simple and attractive method of measuring correlation by diagrammatically representing bivariate distribution for determination for the nature of correlation between the variables is known as scatter diagram method. This method gives a visual idea to the investigator or analyst regarding the nature of the association between the two variables. It is the simplest method of studying the relationship between two variables, as there is no need to calculate any numerical value. We have here the scatter diagram picture. We have perfect positive correlation, perfect negative correlation, low degree of positive correlation, low degree of negative correlation, high degree of positive correlation, high degree of negative correlation, no correlation, no correlation. Even if the scatter diagram shows a relationship, do not assume that one variable caused the other. Both may be influenced by a third variable. When the data are plotted, the more the diagram resembles a straight line, the stronger the relationship. If a line is not clear, statistics determine whether there is a reasonable certainty that a relationship exists. If the statistics say that no relationship exists, the pattern could have occurred by random chance. If the scatter diagram shows no relationship between the variables, consider whether the data might be stratified. If the diagram shows no relationship, consider whether the independent or the x-axis variable has been varied widely. Sometimes a relationship is not apparent because the data do not cover a wide enough range. The next methods of correlation analysis is the correlation graph. Correlation graph is the value of the variable are taken as ordinates of the point plotted. From the direction and closeness of the two curves, we can infer whether the variables are related. Correlation graphs are a visual way of showing if there is a connection between groups of data. If there is a strong connection or correlation, a line of best fit can be drawn, part of application of math statistics. Scatter diagram or the correlation graph is used to examine the relationship between both the x-axis and the y-axis with one variable. In the graph, if the variables are correlated, then the point drops along a curve or line. A scatter diagram or scatter plot give an idea of the nature of relationship. Describe the relationship between variables. It can be described as either strong or weak and positive or negative. Methods of correlation analysis is the coefficient of correlation. Coefficient of correlation is an algebraic method of measuring correlation. Coefficient of correlation is a numerical value. It shows the degree of the extent of correlation between two variables. Coefficient of correlation can be computed by applying the methods given below. The first one is the Carl-Person method. The second one is the Spearman's method. And the last one is the concurrent deviation method. The coefficient of correlation is a statistical measure that quantifies the strength and direction of relationship between two variables. It's a number between -1 and +1, with values closer to -1 or 1 indicating a stronger relationship and values closer to 0, indicating a weaker relationship. A positive value suggests that as one variable increases, the other tends to increase as well. While a negative value suggests that as one variable increases, the other tends to decrease, is the negative correlation. The coefficient denoted by R, which means the range from -1 to +1, with values closer to -1 indicating that you have a strong negative correlation. At kapag meron kang values closer to +1, indicating that you have a strong positive correlation. And values close to 0, indicating weak or no correlation. We have here the correlation coefficient formula of Carl-Person. N is the number of data pairs. Summation of xy is the sum of the product of x and y values. Summation of x is the sum of the x values. Summation of y is the sum of the y values. Summation of x squared is the sum of the square of the x values. And summation of y squared is the sum of the square of the y values. One is the concurrent deviation method. This method is used where the object is just to know in which direction the correlation is present in two series, positive or negative. This method involves in attacking a positive sign for a x value except the first if this value is more than the previous value, and assigning a negative value if this value is less than the previous value. This is done for the y series as well. The deviation in the x value and the corresponding y value is known to be concurrent if both the deviation have the same sign.
The correlation coefficient is a statistical measure that quantifies the strength and direction of a linear relationship between two variables. Think of it as a number that tells you how closely two things are related and whether that relationship is positive or negative. This formula takes into account the individual data points of both variables, ensuring a consistent and objective measurement. The amazing thing about the correlation coefficient is that it's unitless. It doesn't matter if one variable is measured in kilograms and the other in meters. The correlation coefficient always falls between negative and positive. Positive indicates a perfect positive correlation. As one variable increases, the other increases proportionally. Negative indicates a perfect negative correlation. As one variable increases, the other decreases proportionally. The correlation coefficient remains the same even if you change the scale of origin of your data. The correlation between variable A and variable B is the same as the correlation between variable B and variable A. The correlation coefficient is a powerful tool for understanding relationship between variables. Its key features: a defined formula, unitless nature, specific range, invariance to transformation, and symmetry make it a robust and reliable measure in statistics.
Next is application of correlation analysis. Correlation is a statistical tool that helps us understand how two things are related. It's used in many different fields to find patterns and make better decisions. The various fields in which it can be used are economics and finance, business analytics, market research and promotions, medical research, and weather forecasts, better customer service, environmental analysis. The first one is economics and finance. Economics and finance help in analyzing the economic trends by understanding the relations between supply and demand. Economics and finance in correlations helps economists and finance analysts understand how changes in one factor or like supply affect another like demand. For example, if the price of oil goes up, they can study how that affects the price of other goods or stock markets. Business analytics helps in making better decisions for the company and provides valuable insights. In correlations, company use to make smarter decisions by studying how different factors like advertising, spends, and sales are related. Businesses can figure out what's working and what's not. Market research and promotions help in creating better marketing strategies by analyzing the relation between recent market trends and customer behavior. So in correlation, marketing help in understanding customer behavior. For example, if more people are buying a product after saying an online ad, marketers can link the ad or promotion to customer interest or trend and design better strategies. Medical research, correlation can be employed in healthcare so as to better understand the relation between different symptoms of diseases and understand genetical diseases better. In healthcare, correlation is used to find links between symptoms and diseases. It also helps in genetic studies, where researchers look at how certain genes are related to inherited conditions on how different health conditions are connected. Next is weather forecast, analyzing the correlation between different variables so as to predict weather. In correlation, weather forecasts help in predicting the weather by studying how different factors like temperature, humidity, air pressure, and wind are related. For example, if a drop in air pressure is often followed by rain, meteorologists can use the pattern to forecast upcoming weather conditions more accurately. Next is better customer service. Helps in better understand the customers and significantly increases the quality of customer service. Companies use correlation to understand the customer better by analyzing how things like response time, customer feedback, and satisfaction ratings are connected. Businesses can improve how they handle customer issues, leading the faster and more helpful service. Last one is environmental analysis. Environmental analysis help create better environmental policies by understanding various environmental factors. So, correlation is used to understand the relationship between various environmental factors such as pollution, temperature changes, deforestation, and wildfire pattern. This helps scientists and policymakers create better environmental plans and policies to protect nature and fight climate change. So, application of correlation analysis help us make sense of complex data and uncover useful relationships in many fields.